Quick audio check. Testing 1, 2, 3. I'm just going to take that paper bag away from my cat real quick. They will more than likely come up and start meowing when I start talking more. All right, so just a heads up. I have a scrapper going in the background on my other computer. So if you hear a weird alarm sound, I might have to pause the stream very momentarily while I try to get an item. I've been trying to get an upgrade for my computer and it has not been easy. So there's that, but otherwise what I'll be streaming today is development on a server authoritative movement project. This is available to my supporters, but I will be, of course, streaming this publicly, and I intend to stream every little detail, so all of the mistakes along the way as well. Now, I said from scratch, but I already have a few scripts, but they're really small, so I'm just going to show you those scripts real quick. And I'm going to explain them. They don't really do anything right now. They just kind of exist. But the first one we have is the server motor state, and I'm just going to show you it real quick. This is what the server will send back to the client. And I have the client motor state, and this is what the client will send to the server. You don't really need to worry about it right now. I'm just showing you that I already have them in here. So I also have my fixed update manager, and this plays a very, very, very important role. This essentially simulates the fixed update loop because I'm not going to use the standard fixed update. So what I have here are some events. I have pre-fixed update, fixed update, and post-fixed update. And as you can see, there's comments explaining what they do. And I also have fixed frame. So I'm going to actually show you the code and describe what's going on because this is an extremely important part of all of this. I also have update ticks too, and I'll explain that. So the first thing I do in Awake is, like I said, I'm going to manually simulate physics. So I'm going to turn off the auto simulation. So I'm turning it off for 3D and 2D. You'll probably, I'm not using 2D physics in this, so that can just be off anyway. And then under update, so this is a mono behavior, I'm going to call my update ticks method, which I'll show you in a second. But before I get to that, here's my first initialize method, as I call it. And basically what this does is, since it has the runtime initialize onload method before scene load, this is going to pop in before anything else loads, before the scene even loads. So this mono behavior will actually automatically instantiate itself. Now, one thing I did forget to do here is I forgot to make this don't destroy on load. So give me 1 sec, my mic's kind of in the way, I'm just going to move it. Okay, I didn't want to keep bumping it with my hand. So I need to do don't destroy on load, go. And since I'm not placing this in my scene, and I don't actually have to do an instance check on it or anything like that, because it just instantiates itself, and it's only going to happen once. Next, I have my update ticks, which was, as I said, called from update, and this is where I simulate fixed update. So I add on the delta time to my update ticks, and essentially if that delta time is greater or equal to the fixed delta time, then I subtract the fixed delta time from update ticks, and I will then increase the fixed frame, and then I call on prefixed update, which is basically it's just something I added in because I will be using it later, but it's indicating that a fixed update is about to occur, and this is actually useful. Then I'm calling on fixed update. This is similar to the void fixed update that comes with mono behavior, and as you probably know, the physics generally simulate after fixed update, so I'm simulating physics here afterwards. And then I'm calling on post fixed update, which is called after all the physics simulate. So the fixed frame is basically an identifier to what tick is being sent out. And you may have noticed here that I have it in the client motor state and the server motor state. So I will explain what those do later on in the video. I just wanted to point this out. And let's check something real quick. Oh, thanks. My receiver just turned off, so it just repositioned my screen. So I'm going to pause the stream real quick. So give me a sec. Okay, and we're back. So that's really annoying. I always forget about that. Is my receiver has a timeout on it. It's like a power saving option, and if there's no audio going to it, it will turn off, and that resets my my screens, like my extended screens and stuff, because it feeds to the receiver. So yeah, back we are though. No biggie. Let's see. I lost track where I was. Okay. So basically, this simulates our fixed update. Now I have to actually make the motor. So I don't actually have that yet. So let's go ahead and make I guess I need to have like a plane here, I suppose. You'll notice I don't have mirror or anything imported yet. So I'll get to that later. So I'm going to make a plane, and I'm going to make it huge. Okay, and I don't actually have my scene saved. So let me do that. Let's save it as a sample scene for now. I don't know why that box is gigantic. Let's just call this basic rigid body. So in this project, I'm going to actually be showing several different types of movements. I'm going to be starting with a rigid body because that's definitely the most complicated and the one that people look for the most. I'm going to have a basic rigid body scene, and I'm going to have a complex rigid body scene, and they're going to do different things, which I won't get into right now. But to start with the absolute basics, we'll be doing the basic rigid body. So let's go ahead and take this. I'm just going to move this down like 2 units, and I'm going to make a new folder and call it prefabs, and I guess I need to import mirror. So let me go ahead and do that. Could you load any slower? This is not my internet. It is just being slow as heck. Okay, going down, going down. Oh, there's an update. Lovely. Okay, so let's see. I have it over here on my other screen, and I'm just unchecking things. Don't want the examples. I think that's it. So I'm gonna go ahead and import. KCP. That thing is evil. It has so many issues. They really should not have dropped it in without thoroughly testing it, but it is what it is. I'll probably be replacing that. Actually, I'll definitely be replacing it with an unreliable transport. KCP is UDP, but it's reliable only, which is a funny joke. So that'll be going away. But not going to worry about that for now. Let's make my character. So I'm going to do a 3D object. I will do a sphere. Okay, so I'm actually going to make a new object. I'm going to call it player. I'm going to drag the sphere underneath it. Make sure everything is zeroed out here. And then under this, I'm going to add a network transform. I am going to use the mirror default components. Now, I obviously have some components that are going to work way better than the mirror default components, but I'm not going to be using those in this stream. I will probably replace the mirror ones with my own whenever I feel necessary. But for right now, for setting everything up, I'm just going to use the default components. So I have a network transform, which is not client authoritative. Now, I noticed there's no synchronize to owner option. I think it automatically synchronizes to owner whenever this is unticked, which means this is already not going to work. So guess what? It is now a necessary time to upgrade to my components because network transform sucks. Okay, so let's go ahead and do that now. I'm not trying to bash mirror, but it does suck. It sucks hard. Okay. I might need to download my components. I don't know where they're at. Just give me one sec. Just gonna download this. Save. Going to drop it on my desktop, which is a giant mess right now. I know you can't see what I'm doing, but I'm doing things on the other screen. So now I'm going to import it. Desktop. Okay. So I really only need my Flex network transform right now. So let's get rid of this and this and this. Import. The stream will be present up until the project is released. Once the project is finalized and released to my supporters, I may pull the stream down. I'm not sure yet. I'm just saying that is definitely a possibility. Okay. So let's go see. Let's take off network transform because it's garbage, and let's add on Flex network transform. I will be using reliable because I'm on a reliable transport right now. Although if I did untick reliable, it wouldn't really matter because you can still untick reliable on a reliable transport. It'll just default to reliable. So I'm going to change the synchronized interval to let's just say 0.05, something kind of in between, not too fast but not too slow. And let's change this to 0.3. Untick client authoritative. I won't be synchronizing scale, and I don't actually care about rotation, but I'm going to keep it on there. So this is a synchronize to owner option I was talking about, which I think is automatic with the default network transform. When checked and Flex network transform, it will force the client to the server position when not using client authoritative. However, when you're using server off movement, you won't want that kind of behavior. You'll be doing that manually. So I'm going to untick that. Okay, and I actually want precise synchronization, which just means anytime the transform is changed even a little bit, send an update. And Don't really need it, but I'm gonna keep it in there. Actually, no, I'm not. Changed my mind. All right, so let's go back to scripts. First things first, I guess I need a motor script. So let's go ahead and make a new script, call it motor. And reload, because something blew up apparently. Reload again. Let's go ahead and try reopen that. Okay, so I'm gonna go ahead and just take this, paste, and just change this to motors. All right, so first things first is I need to hook into the fixed update. I love how everything in my house decides to be noisy when I live stream. It probably happens all the time and I just don't notice it. Now I'm trying to think if I need to hook into it for all clients or just the owning client. I think I need to just do it for, I'm gonna do it for all clients just because I want to show you an example. So I'm gonna do private void awake, and this is also the server too, so all clients in the server, I suppose. Update manager, add the namespace using .on prefixed update, and I'm gonna do, actually, am I gonna do prefix update on the motor? No, I'm not. I'm going to actually just do on fixed update. Okay. So this is where I'm going to track my inputs and all that jazz. Now, on awake, let's ignore that for a sec. Let's go ahead and put in network behavior. And I need to get my rigid body. Rigid body on this object. I'm going to add comments along the way so that I don't have to do all this at the end. Plus it can get really messy if I don't do it right away. Okay, so I'm going to do private void network first initialize. I'm going to do override on start server, and I'm going to do actually I do need the rigid body for everything. I'm kind of thinking in my head the ways I'm going to do this. I'm actually just going to copy this. So I like to do things where I call first initialize and first network initialize. And this is basically for awake or start, and this is for things like on start server and so on. And I'm actually going to take this and I'm just going to do first initialize. All right, so here's the thing. Now, I'm going to keep my rigid bodies as simulated / non-kinematic. That way, basically, they're active on all clients. So, or and the server. Now I'm going to go over to this real quick, and I'm just going to copy this. I don't actually need these open. I'm going to close these. Just change that to received. So the reason is I'm going to do this private void cancel velocity boolean use forces. And I'll explain what I'm doing here in a second. So if use forces, then I'm going to simply do rigid body.add force negative rigidbody.velocity force mode.impulse. So that's going to cancel out the velocity. And I'm going to do rigidbody.add torque, and basically same thing, rigidbody.angular velocity, again, force mode.impulse. So I found a funny little thing where if values are, I want to say if they're too high or too small, I think it's if they're too high, then if you actually cancel out force by doing this, which theoretically shouldn't be an issue whatsoever, it will do some really weird things, and it will actually make like an excessive amount of force, and then it builds up and things just go crazy. So I'm going to add in the option to not use forces. And like I said, theoretically it should work according to the physics engine, but the physics engine is not perfect. So it might not cancel it exactly to 0, and that could cause problems. So I'm just going to do the alternative, where I can do equals vector 3.0, and same thing here, where I can also zero them out without using forces. Okay, so now I have my on fixed update. Now, what I'm going to do is if not base.has authority and not base is server, then cancel velocity. And this should only be called on the client. So I'm going to put a client attribute up there, and I'm going to not use forces. So basically what I'm doing here is if you're a spectator and you're not the server, so not client host basically, then I'm going to cancel the velocity on the object. What this will do is it will prevent the physics from running on objects which you do not own, and instead it will rely on the flex network transform. And you're probably wondering, why the heck would I do that? Well, because, or rather, why don't I just make it kinematic or non-simulated? And the reason is because if you do that, then your rigid body won't be able to pick up collisions. So if you run into that other object which you don't own, the collision won't be picked up. So instead, I'm going to simply zero out the forces on it and keep it as non-kinematic or simulated. All right, so next thing I need to do is send inputs to the server. So let's just take a quick look at that. I'm going to do if base.has authority, and I need to make a new method. I don't know if I want to call it send inputs. I guess I'll call it gather inputs. I might change this later, it doesn't really matter. And I'm going to call send inputs. Okay, so I'm going to do client send inputs. And obviously you don't have to leave your method names with client, but I'm doing this because it makes it a little more clear as to what I'm trying to do. And I know like I could just do this, but I want to be able to be like, oh, this method is what's sending inputs to the client. It's just kind of a thing I do that helps keep things organized whenever I expect to have different methods, but that are similar in what they do when there's server and client specific ones. So that's just what I'm doing here. Now, I need to gather my inputs, and then I need to process the input, and I need to send it to the server. So first I'm going to do private void process inputs, and I think I just want to pass in the client state. No, I'm going to yes, I am going to pass in actually the client motor state, which I'll now talk about that in a second because I'll be using that. So what we have here is we have fixed frame, which is the frame that it ticked on, or which the input was sent on. And I have the inputs, which is horizontal and forward. Then I have action codes, which I have do not think I'll be using the stream because that is going to, I don't think I'll have time for that. But the action codes are basically going to be things like sprint, jump, etc. In order to re-simulate a state properly, you have to store everything that was called on that frame or used on that frame. So, for example, let's say I'm moving. Actually, I guess I need to kind of explain how this works first before I can explain why we need that. So let's say I'm on the client here. I'm just going to add a bunch of these so I can type it out. And on the client, I am sending, let's just pretend these numbers represent the fixed frame. So I'm sending 1, 2, 3, 4, 5. Now, let's just say the server gets, let's say client to server. And then let's say the server gets input 2. So the server is going to say, okay, I got input 2. Let me just make this a little more clear. Okay. Server is going to say, all right, I got input 2. So it's going to send that back to the client with the server motor state. So let's just take a look at the server motor state real quick. So what's going to happen is the client will send inputs to the server, and the server is going to apply those inputs. Basically, it's going to say, okay, you moved horizontal so-and-so and forward, and let's ignore the action codes for this time being. So the server is going to see that it moved horizontal and forward, and inside my motor script, it's going to take those values. So let's just say if horizontal is 1 and forward is 0, it's going to call process inputs for everything received, and it's going to move the object on the server. Now, the tricky part is the server has to send back to the client where it resulted after applying those inputs. So what it's going to do is it's going to reply back with the fixed frame, the same one that the client sent to the server. So in my example, it'd be 2. It'll respond back with the position and the rotation of the transform after applying those inputs. And since this is a rigid body, also the velocity and angular velocity. So what will happen at that point is the client will say, okay, well, server sent me 2. So we'll just say client got 2. So the client's going to say, okay, so the server sent me back 2. And it's going to reset to data, let's say server motor state 2. What it'll do is it'll maintain a list of all these inputs. It'll find the fixed frame, which matches 2. It's going to, actually, ignore this part. It's going to reset to where the server tells it to whenever it receives the update. And then it's going to look for the fixed frame of 2, which is basically the server saying the last frame I got from the client that I used was 2. And it's going to then remove these from the values which are being stored, and then it's going to reapply these. So what's going to happen is the client is actually going to move forward. So let's say if the client is here, this first dash, and then it sends to the server, and by the time the server gets back to it, the client is here at this highlight, but the server says the client's here. So now naturally, if you go from here to here and then to here, it's going to rubber band and it's going to look really gross. So what's going to happen instead is that actually is still going to happen. It's still going to teleport the client back, but then it's going to reapply the inputs that got the client back to here. And in result, the client should more or less end up right back to where it started, as long as it didn't fall out of sync. And that's essentially what's going to happen with the input rollback. Now, the thing that is a little trickier is, and this brings me back to the action codes. Now, you also have to store in your action codes like sprint, jump, etc. This is a byte, but it's going to be an enum. Just a heads up. So what I need to do is let's say on 3 I jumped. Now if I roll back to here but I didn't store my action codes for jump, then my rollback would just be in a different spot completely, because the object wouldn't jump. So it would just keep using the angular or the horizontal and forward, and it would just be moving in a straight line. So in order to reapply the inputs exactly as they occurred, you have to store every single state that could possibly affect your motor. And that's where the action states come in. And that's probably really confusing. So I hope when I do show that, it'll make more sense. But for now, let's go ahead and proceed. Now I'm going to do float horizontal equals input.get, and I'm not going to use the new Unity system. I'm going to keep everything pretty vanilla. Plus, I like rewired more anyway, but we're not going to talk about that. All right. So give me 1 second here. I'm going to pull up a reference bit of code. And I'm actually going to get a quick drink. I'm at the half-hour mark, so I'm just going to get a quick drink. I'll be maybe like a minute at most. Okay, so as mentioned, we're going to have to actually store the states, and this is where we would do that. So I'm going to go back up top, and I'm going to make a new collection. That was supposed to be a list. And this will be client. I guess I would say stored client motor states. I know that's not very descriptive, but you'll understand it later. And I'm also going to need one for server. So I'm going to do private server motor state. Server motor state. Now notice that this is just one, it's not a list, and I'll get to that later as to what I will be doing with it. Most current motor state received from the client. I'm actually gonna probably name this something different. Give me 1 sec. What would be a good name for this? How about client received, or received client motor state? That makes more sense. Okay, so now I'm going to go back down here, and like I said, you have to store your states. Someone did tag me on Discord, but I have my audio off for the desktop, so I don't know how you would have heard that, and that might have been an old tag. I'm not really paying attention to Discord right now. So anyway, I'm going to go ahead and do client motor states dot add. I'm going to actually just make a new one here. I'm going to do client motor state equals new client motor state. Okay, so action codes for now equals 0. fixed frame equals fixed update manager dot fixed frame, easy peasy. Horizontal equals horizontal. See where this is going, pretty straightforward, right? No pun intended. Forward equals forward. All right, so I successfully generated a state, and now I'm going to add it to my motor states. So let's just add the state, and then I need to process the state locally, which the inputs, whatever, and I'm going to pass in state, and now I need to send those to the server. Yeah, it's no biggie. I mean, it's fine if you sent me a DM. I don't ignore them intentionally, but I often overlook them because I get like a lot of DMs. So that's why I highly recommend people message me on my server and not in a DM. So now I need to actually add a command to accept the client motor state. So let's just see here. I have client send inputs. I guess I need server. So I'll just do command send inputs. And again, it's going to take a client motor state. This is obviously going to be a command because I led it with CMD. I know you don't have to lead it with CMD on Mirror, but I very much highly recommend leading your commands with CMD. Target RPCs with target and client RPCs with RPC. It's more clear. It's kind of just a general good habit for design. And also there's general cases where you will want to have the same method name, and you only want, like, you want it to be clear if it's like a command, if it's going to an RPC and things like that, which actually reminds me, I probably don't really want the clients there. I'm just gonna do send inputs. Okay, so now I'm going to do if well, I should say if base is client, but I'm already only calling this from client. So I'm just going to do command send inputs, and I'm going to send the state. So what's happening right now is I am getting my input, and then I am storing it in a state. I'm adding it to the states collection so I can roll back and reapply. I'm processing inputs, which has nothing in it right now, but this will move my rigid body. And then I'm sending those inputs to the server. This is indeed client prediction, yes. This is what most people ask me about. So yeah, but this is client prediction, server reconciliation, or whatever, and all that jazz. Send inputs from client to server. Yes, I'm sure you don't need to lead it with a CMD if you're on a newer version of Mirror, but you always should. You always should. Do not lead it with a CMD or some leader. Now, it's not going to break your project if you're on a latest Mirror, but don't do it because it's bad. It's bad practice. Don't get in the habit. Just don't do it. Always lead with a prefix. Okay, rant over. So now I need to do this. Now I'm going to do if state dot fixed frame is less than received client motor state dot fixed frame, then return. So let's see, if input is, or if input, let me change this. If state received is older than the last received state, then ignore it. Now, you can't do this per se if you're using a non-reliable or unreliable transport, because let's say the old state is contains jump code, and because you're using unreliable, maybe that jump code ends or comes in after a different state, and this would ignore it, but that jump is crucial. It has to be done. So there is there's another way to handle that, and I do it in FPS land. You basically have to send multiple states per packet. So like I send the last 3 states, and the error chance of one of those being dropped is like slim to none. It's less than 1%. It's like a fraction of 1%. I know some games even send like the last 10. I think Rocket League, I think they said they send the last 10 states, but they're also running at 128 tick. So there's probably a higher chance that the packets are going to drop because they're sending so many. I'm not going to tell you how many you should or shouldn't send. If you want to be extra thorough, you can probably send like 5 or 7. But I use 3 in FPS land and it works out really well. But that's also only running at 64 tick. Anyway, so this is under the assumption that I'm using a reliable transport, which for the time being, since this is a simple auth movement, I will be using a reliable transport. And like I said, I'm going to have different demos inside this project. So there is a extremely good chance I will switch to an unreliable at some point, but it'll also be a completely different demo. Like the code's going to be more or less the same. So I have like a motor script here, and the motor is going to be ultimately more or less the same, but the difference is I'm going to make an entirely new copy of it with like a new namespace and a new folder and all that stuff. So that way you could go from simple to moderate to really complicated, handling different, scenarios. And that way I don't just drop something that's either too simple or too complicated on you guys. That way you can actually look through it. So now I'm going to add receive client motor state equals state. So I know I got sidetracked. Basically, this is the wrong thing. This should be client motor state. There we go. So basically, if the state is a newer state, then it's going to set it to the receive client motor state. It's not going to do anything with it right now. So everything has to be processed in fixed update. So I'm not going to do it when the command's received because that's done in late update. Mirror doesn't run stuff in fixed update, which kind of sucks, but it's okay. We can still work around that. So we're going to store this, and then when the fixed update comes around, that's when we will run it. Now, I'm going to go ahead and go to process inputs, and before I get too complicated on setting up my rollback and all that jazz, I'm going to make sure that everything works locally, because it would be kind of funny if I set up my motor and it doesn't even run locally like single player. So, which I don't doubt will happen. So let's go ahead and do that now. And yes, this will be available to patrons. Okay, let's see. Processes input from a state. All right. So, I guess I just need a new. I'm going to add something up here real quick. Private float move rate equals, I honestly don't know what to start with. I'll just say 1F, or let's just say 3F. Move rate for the rigid body. This is basically a multiplier that I will be applying towards my forces, or my inputs. All right, so I'm going to do vector 3, forces equals new vector 3. And I'm going to do x equals motor state dot horizontal times move rate. Now you will definitely want to clamp these to ensure, for example, I'm using get access raw, so I expect always a -1, 1, or 0. So you're going to want to clamp those to make sure the client doesn't cheat. So let's just actually do that real quick, shall we? So let's do all right. So I actually have a method called precise sign in one of my other one of my personal scripts. So I'm going to find that real quick because I'm going to need that. So give me 1 second. Going to go back to here, and I'm going to make a new folder. I'm going to call it utilities, and I'll make a new script, call it floats. This is just something I've had for like forever. I have like a collection of things that I use that I use with pretty much everything. So I'm gonna go like this and just paste a bunch of code. You don't really need to worry about this. This is just a helper script. I'll explain what it does in a second though. Oh no. Okay. I need my ints one too, so let me grab that. Whoops. Like I said, these are just helper scripts and they're not really related to the motor, so I'm just gonna paste everything in all. Okay, bye-bye errors. All right, so now what I'm going to do is I'm going to clamp my inputs. So I'll do motor state dot forward or horizontal equals floats dot precise sign motor state dot horizontal. So basically, what if you do a mathf.sign, it's going to return -1 or 1. But if the value is 0, it's going to return 1. And we obviously don't want to change it to 1 if there's no input. So my precise sign method, all it does is if the value is 0, it returns 0. Otherwise, it calls the normal mathf.sign on it. So all it does, it just saves some typing and makes the code a lot cleaner. I'm going to do the same thing with this. Okay, I don't think there's anything else I have to check. No. Okay, back to what I was doing. So this basically ensures that they cannot speed hack by modifying the horizontal or forward inputs by an excessive amount. So I don't actually need the move rate part on here just yet. There's no... These inputs only apply on X and Z for horizontal and forward. So motor state dot forward and times move rate. Let me just check something real quick. Yeah, so you don't I always forget this too. You don't apply delta time or fixed delta time when adding forces, I believe. And I always forget this all the time. So basically, just to show you what that looks like without all the separation, it looks like this. So I'm taking the horizontal, the forward, and then multiplying that by the move rate. And I'll just keep it like this. This is simple enough. Sometimes I just break things down when I'm writing them, so it's easier for me. So now I'm going to do rigidbody dot add forces and force mode dot force. So regular old force mode, which is the default. I'm just dropping it in so you guys know, so you understand. So this will apply the force locally, and I guess now I need to test it out. But I know I need to set up my manager and stuff, so let me go ahead and do that. Hey F home, welcome to the server again. I heard what happened. I'm sorry about that. So I added in my network manager. I'm gonna get rid of this because it's Junko. Gonna put on this, which is also Junko, but it's less Junko. Ignoring this warning real quick. So anyway, now I need to add, I don't have my player as a prefab yet actually, and I don't have the motor script on it. So I'm gonna drop the motor script up near the top, I suppose. Move rate 3, that should be fine. Just double checking everything. Notice I do not have server only checked. That does have uses, but not in this case. Okay, I'm just looking over these errors real quick. Network manager. Flex network transform child. Okay, these are just meaningless warnings, but I'm going to assign default values, which will actually make them go away. So if you ever get sick of seeing those warnings, just assign default values. And there you go. This is Mirror's issue, the network manager, so I'm going to ignore that. Never seen this before. It's definitely a bug, that little warning thing, so I'm going to ignore it. Let's go over to my folders here, and I don't have a prefabs yet, so I'm going to do prefabs. And let's drop my player in there. Now I'm probably forgetting something. I almost guarantee you I'm forgetting something, but that's why I'm doing it now before I go crazy and write a bunch of code. Yeah, I need to add the HUD, I guess. Adding the network manager HUD. Client host. Object ref. I didn't add a rigid body. So let's go back to my player prefab. Rigid body. Okay, so getting errors. Let me see exactly what's going on here. Did I forget to get the rigid body? I did. Okay. This is what I was saying, that I should probably, test everything before I go too far. This is all obviously really small stuff. It's just things I don't want to bite me in the end, unexpected. Okay. Yeah, so it's rolling around. I think I'm gonna boost the motor speed though, because it's kind of slow. So let's just go like 10. Okay, that's a little bit better. We'll go with that. Now we'll drag 10. Okay, that's too much, obviously. So I'm gonna change this to like 20. I'm gonna tweak this at runtime. That feels acceptable to me. It moves pretty much instantly. And I don't know if you guys can see it, but this looks even funny in here. It's probably because I can just see it. I'm on a 240 hertz monitor, so I can actually see like the stuttering between frames because I'm only running at a fixed step of 50 times a second. So that means I'm only getting 50 updates on the physics. And I can actually see that. That's driving me bonkers, but it doesn't mean anything's broken. So I'm going to ignore it for now. So I'm going to use a move rate of 20 and a drag of 1 on my player prefab. Okay. So that is now working, at least in client host, of course. So, like I said, now I'm not going to, this is assuming that states are reliable. I'm using a reliable transport right now. Now, I also said that I'm only going to use the one state at a time received from clients instead of running them as I get the command. So this presents a small problem. Let's say let's say I get 2 inputs. Sorry. Let's say I get 3 inputs in one frame. Let's just say some reason the client burst sent me inputs, which shouldn't really happen, but it can happen. It can most definitely happen. So let's assume the client sent 3 inputs. Now I'm only setting this once, and then in fixed update I'm going to run only 1 input. So basically what will happen is 2 of the inputs will get dropped, and that's obviously going to cause a desync, which is bad. Well, it's not bad because it's going to correct itself, but it's bad in the sense that it can be avoided. And to do that is actually really easy. So before I show you how to do that though, well, let's just go ahead and set it up, kind of the preliminary on that. Just so maybe you'll see where I'm going with this. Const, I actually only need like a byte for this. Maximum client state predictions equals 20. Maximum times the server can predict a client's predict the client state. So this is actually something Rocket League does. I watched the talk they had, and this is actually something they do. And this actually occurred to me before I saw the video, but it's really nice to hear that a lot of bigger studios are doing things that you're doing. It's just reassuring. I'm always interested in improvement though. So if anyone knows something I don't, feel free to let me know. So anyway, maximum client state predictions, and what Rocket League basically does is if they don't receive an input from the client, then they will try to predict their next state. And it's reasonable to assume that if the server receives 3 inputs at once, then more than likely they didn't receive inputs for at least 2 frames. So that's where the prediction is going to come in. Now, the alternative is if they did receive 3 inputs at once, then the client is probably trying to speed hack or something. Now, if they received an input last frame, this isn't going to do anything for the client because I'm only saving 1 input at a time, and I'm only going to run 1 input per frame. So this works great in the sense that it prevents clients from speed hacking or sending excessive inputs and things like that. It's really helpful in that way. Now, the only downside to this that I've seen is by predicting states instead of using exactly what you get from the client is sometimes prediction's wrong, and that happens. But if it does happen, it's going to cause a desync, and then the client's going to have to adjust visually, and that's something I'll cover later. But it definitely does happen. I haven't really seen it happen a lot on objects that move at a typical rate. For example, the desync is usually very small, and you can adjust very easily and quickly. For very fast moving objects, however, it sometimes can be much more brutal. Still, good adaptation code for that will fix the desyncs though, the visuals anyway, and it pretty much works out in the end. But anyway, now I'm going to do if base.isServer, then what do I want to call this? I swear I struggle more than anything trying to think of how I want to name my things. Often what I'll do is I'll actually go look at other projects and I will follow the same naming convention that I used at those times. And the reasons I do this is because it just helps me kind of remember, especially between projects, it helps me kind of remember where I'm at and what each thing does. It maintains a very similar code base. So I guess I'll just call this server or process. Let me see here. This is long as heck. What? This method name is stupid long. It's okay though. So we'll just go somewhere. I don't really know where I want to put this, but I'm just gonna put all my commands and stuff at the bottom. Private void. What did I call it? Process received client motor state. Okay. All right, so first of all, I actually want to make this a nullable type. And the reason for that is because I want to do if receive client motor state equals null, then return, meaning nothing has been received yet, so I can't do anything. Naturally, I'm going to get an error because this doesn't know if it's null or not. So I'm going to do if receive client motor state doesn't equal null, and state fixed frame, so the current state fixed frame is less than the last fixed frame. So whenever you make something a nullable type that normally isn't, you have to access the data on it, you have to do dot value. So just keep that in mind. All right, and this would make it non-nullable by assigning it value. So that's a nifty little thing if you didn't know about it, and you can do it with pretty much anything. You can do it like ints, structs, all that great stuff, and it's super, super, super useful for things that have like a default value of 0, where you might also want to use the value 0, but you want to know if it's default value, or like, for example, if it's the initialized value, or if you actually set it to 0, you can make it a nullable type, and you'll know that if it's, you know, not null, then you set the value. So very useful there. So let's see. The first things first is I need to make sure that if the state equals null, then return, because I can't process a null state. Now I talked about predictions or predicting input, so here's where I'm going to do that as well. So private byte remaining client state predictions equals 0. Number of predictions left that the server may use. Okay, so now I'm going to go back to the command, and whenever it receives input, it's going to also reset the client predictions equals maximum. And where I'm going with this is essentially whenever it gets a new state from the client, it resets the number of predictions it can use on that state. So in addition, I'm going to do if the received client state is null, or if remaining client state predictions equals 0, then return. The chances of this going to 0 are not very likely. So if I'm running at a fixed update of 50 frames a second, and I have it set to 20 predictions, that's like, it's like what, 300 milliseconds? Maybe my math is wrong, but let's just say it's 300 milliseconds. That means you'd have to go without receiving an input for 300 milliseconds before it actually, before it stopped using a prediction. That might actually be high. So you'll probably want to adjust that to your game type, because to me, 300 milliseconds is a lot to use predicted movement, because a lot can happen in 300 milliseconds. So I would probably try to keep it to like 100 milliseconds. So you'd have to adjust the prediction count to based on your frame update rate. And that's just kind of all up to you. It's not really hugely important or anything like that. Next, I'm going to do something here that probably won't make sense. I'm going to do bool new input equals remaining client prediction states equals maximum client state predictions. So basically what this is going to do is it's going to say if this is the first time running this state, so the received client motor state, the new input is true. And the reason I'm going to do that is because I'm only going to send a response back to the client if I am processing new input. So I'm not going to actually send a response back to the client for every predicted input. 2 reasons. I don't really think it's necessary. I haven't really noticed a difference between sending back every input versus, every predicted input versus only the new inputs. So by only sending a new, I'm saving bandwidth, and it's also less chance that I'm clogging up the client. So I'm only going to send a response back if it's a new input, and the client will always send updated inputs. So eventually they'll fall back into sync, and it just kind of works out in the end. It's just something I played around with, and it works out in the end. So now that I have all these checks in, I suppose I need to just go ahead and process the input. So I'm going to go ahead and process inputs, and I'm going to use the received motor state. I'm going to use received motor state or client motor state dot value. So let me add some comments. True if this is the first time this input is being run. Okay, and now I'm going to process input of last received motor state, and I also need to remove from the predictions. So I'm going to do remaining client side predictions -1 basically. Okay, now here's where I said basically if it's a new input, then I'm going to send that input out. So let's do if new input, and I need to generate a server motor state, and I talked about that briefly, where this basically contains information about the transform, the rigid body, and all that after the server applied these inputs, and then it sends it back to clients. So I actually missed something that I'm going to show you in a second. I need to check something real quick. Okay, no, I didn't. I did not mess up. Okay, I just realized that I was thinking in one of my paid projects that I might have made a mistake, but I didn't actually. So carrying on. So now I need to actually make a new server motor state for this. So that would be, I'm just looking on a different screen here. Server motor state. I'm basically using some other stuff I've done in the past as a reference to keep things fresh. Response state equals new server motor state, and fixed frame equals, and this is going to be the fixed frame received from the client. So this is part of the rollback I talked about, and I'll explain further in that, or re-explain very briefly what's going on. Position equals transform dot position. Rotation equals transform dot rotation. Velocity equals rigid body dot velocity. And angular velocity equals, of course, rigid body dot angular velocity. Okay, so now I need to send this back to the client, but I don't actually have a method for that yet. Send results back to the client. Target. I'm going to send this to the owning client because, again, the owning client is sending inputs, the server's processing it, and it's going to send it back to the client. And I'm going to pass in the response state. Now this method doesn't exist yet, so I have to go add that in. So let's go ahead and do that now. So let's see, private void target I'm going to be ending the stream here soon because it's been running about an hour and 10 minutes. I don't know if I'm going to be able to finish up the rollback and stuff yet. I think I will try and finish it up real quick and see if everything is working. If not, I'll have to save it for next stream. So target server state update network connection. This is just the connection it's being sent to. Worth noting, if you don't specify this parameter and you don't specify it when calling this method, it just defaults to the owning client. But I like to explicitly state where it's going, and that's just a personal preference. Okay. Received on the owning client after the server processes client motor state. Okay, so now I need to actually make a new value here. Similar to what we did with the client, or the server, I need to make sure that I don't overwrite a newer value with an older value. So I'm going to do private server motor state nullable type received server motor state equals null. Most current motor state received from the server. So this is what's going to be sent to the client from the server. So like before, I'm going to do if received server motor state doesn't equal null, and state dot fixed frame is less than received server motor state dot value dot fixed frame, then return. Basically, exit if received state is older than the most current, because we don't want to snap back to an older state after applying a newer state. And this won't happen with a reliable transport, but it will happen with an unreliable one. Since I'm using a reliable one in this example, this is kind of moot. It doesn't really be needed, but I'm just keeping it there and explaining so you guys know. Now I need to do receive server motor state equals state. Okay, so what's going on now is the client is processing inputs locally. It's sending those inputs to the server. The server is then storing that value, and whenever fixed update comes around, which is right here, it will process that received value and it'll do a little bit of prediction magic, which is obviously very simple. It's stupid simple. And if it's the first time processing that new input, it'll tell the client of the results, and then the client will store those results. Now I need to roll back the client to those results, and that's where the rollback code comes in. So that's going to be done under, again, fixed update, because this is physics based. So under base has authority, before I send new inputs, I'm going to process received server motor state. I need to make a method for that, obviously. So let's go down, and I guess I'll just put it right here. I'm going to probably region this all up and make it nice and pretty, but for now it doesn't really matter. All right, so this, just to be clear, this is run on the server, and this is run on the client. Let me just make sure I didn't miss anything else here. This could be run on either client only, command, and guess who forgot to put the target RPC in there? Okay. All right. So processes the last received server motor state, and I guess I don't really need to explain what it does further than that. So let's go take a look at this real quick. Now, like before, we're basically gonna copy this, but you're not gonna use prediction on the server motor state because there's just no reason to. So we're gonna do received server motor state equals null, then return. You can't process it if there's no response received. So if you're using an unreliable transport, like I said, you would have to send states multiple times in one packet. So you'd have to somehow filter out which ones you've already processed and which you haven't. But for the sake of simplicity, we're going to assume that the most recent one is always the greatest one. Plus, we have the extra check under the target RPC. Probably should just forget I even said that because it's not really relevant to this simple example. So what I'm going to do is I'm going to I suppose I'll do server motor state state equals receive dot value, and I'm going to nullify it because I only want to process it once. And this is just for the sake of typing it, shortening, what I have to type every time. So now I need to do, and I'm going to be using link. There are definitely more performant ways to do this, but I'm going to be using link to determine the index in my stored client motor states, because if you remember, whenever I send inputs, I store those inputs in client motor states. So here's back where I was talking, where we're going to re-roll all that stuff. So first I'm going to do index equals client motor states dot find index, x equals x can be anything you want, it's just a variable name of whatever you like. Fixed frame equals state dot fixed frame. So basically I'm going to find where the state from the motor received is inside my client motor states. And it should always be in there. There's no reason it wouldn't be in the motor states, but just in case, I'm going to do if index doesn't equal -1, then I'm going to remove up to and including that state. And I'll explain why in a second. So client motor states dot remove range starting at 0. Index +1. The reason I'm doing +1 is because let's say if the receive state is only is at index 0. So I have 5 states in my queue here, client motor states, and the one I received is for 0. Then I'm going to start at 0, but I have to remove the count of index +1, because if I remove 0 entries at 0, then nothing was removed. So I'm always going to add +1 onto it. So let's just say remove entries which have been handled by the server. Now I need to snap my transform back to where the server said it was at that state. So basically this is going to snap the transform back to where the server says it was after it applied inputs. Snap transform to server values, or I should just say snap motor because it's not just a transform. So I'm going to do transform.position equals state.position, transform.rotation equals state.rotation, rigidbody.velocity equals state.velocity. You can see how this is kind of like really easy to follow. It's not really, it's kind of a tricky thing to wrap your head around, like going back and forward, but the code itself is actually really, really easy to follow. So let's do rigidbody.angular velocity equals state.angular velocity. And I need to call physics, and this is a 3D example. So I'm going to call physics.syncTransform. If this was a 2D example, you would want to use physics 2D. So the reason I want to do this is because after I teleport my transform back, I want to tell the physics engine that it's at that position right now. If you don't call this, then it won't actually put the transform at that position until the next fixed frame. So for example, let's say if X is where I'm telling it to snap the transform back to, and Y is where it's at currently. So even though if I set the position back to X using this code, if I don't call sync transform, it's going to remain at Y until the next fixed update runs through, in which case I'll say, oh, the transform is now at X. So that's where we're going to set it. What this does is it basically sets it prior to, or rather than waiting for the fixed update, it sets it right away. And this is important because of what we are about to do. So now I need to do, I'm going to do for each, and this could definitely be a for loop, a regular for I loop, or it could be other optimization types. But I'm going to use a for each. Can't use state because I already used that. Which means I'm going to actually just change this to, here we go, in client motor states. So what I'm doing now is, like I told you, is it's going to find the index and then it's going to move up to that index. And then it's going to snap the transform to the server result and then reapply inputs that were sent since then. So this is where you're seeing all that come together. So let's say 1, 2, 3, 4, 5, 6, whatever. And the server comes back with 2 like before, and I snap to the position of 2. And this code right here is going to remove 1 and 2. And it's going to leave 3, 4, 5, 6. And what this is going to do after you snap back to 2 is it's going to reapply 3, 4, 5, 6, which more or less should put it right back to where it came from. Like I said, there's a chance for desync, but that's where we will adapt later on. So now I'm just going to do process inputs, and very simply, I'm just going to call client state. Now, here's the thing, is after you process inputs, you have to simulate physics, because you might bump into something. Let's say the server snapped you back to a different position, and on your screen previously you didn't hit it, but on the server side you did. So it snaps you back, and if you don't call physics.simulate right here, and again, if you're using 2D, it'd be physics 2D. If you don't call physics.simulate, then it simply will not register that collision, and it'll apply all the forces at once, and then it will simulate them next frame, which is not great. So you want to apply the forces according to the state, the actions, whatever, and then you're going to simulate every rollback. So that's what's going on here. And that's actually it. That's all you got to do for client prediction and rollback. Let me make sure I'm not missing anything. I don't think I am, but let me just double check stuff real quick, okay? So let's see. I got my cancel velocity if not owner. I already explained what that's all about. I got process received server. That's the rollback code. And then I have where I send inputs, which also moves locally. And then if the server, I process the client received data. So yeah, that appears to be everything. Why don't we test this out? Now, first, this should run on client host, but we're gonna find out. Oh, I broke it. Okay, didn't work. Something went terribly wrong. I'm going to figure out real quick what that is, though. Now, we know it was working before this, so I'm going to comment that out. It might also be this, too, because it's processing the states twice because I'm a client host, so maybe I'll add a quick check to that. Okay, so it seems to be the rollback, and I suspect that if I don't uncomment, so let's just see how quickly it moves from one side to the other. Okay, now if I suspect if I comment out this, it's probably going to move slower because I I believe it is running the states twice now, and I just want to make sure. No, you do not need to call the physics sync methods if you're using a character controller. It's actually a lot easier if you're using a character controller. Okay, so it is definitely moving way slower on the client, because what I said previously is that it's sending it twice because of the server. So I have to make an executive decision here. So I'm only going to process inputs if not base is server. Only send inputs if client only. Oops. There we go. Since sending inputs here otherwise would result in them running both on client and server. This would result in inputs running twice in one frame, or twice in general, but yeah. Now if you're not running as a client host, this isn't going to be an issue, but it's just there because you're probably going to do some testing in client host, maybe, I don't know. So I'm going to comment this back out, and I'm going to quickly make sure that it is not moving twice as fast, which it shouldn't be. No, it's moving at the right speed now. I can tell because it's definitely slower. So there's something wrong here, obviously, because last time I did this, it just froze in the air. So let's just see if some reason that fixed it. No, it didn't. Okay, so what could be going on here? Let's just do a debug.log client motor states.count. I expect this to be maybe like, I guess it'd be like 0 or 1 because I'm running client host. Yeah, it's gonna be 0. So trying to figure out what could be going wrong here. We know it's the rollback code that's causing it, but why? So let's look at this real quick. I'm calling simulate after I call fixed update, so the physics should simulate, which means the gravity and such should kick in. I might have to make a build. Okay, so we're gonna do a quick build. I know that it's receiving a motor state because if it didn't, it would just exit the method and it wouldn't stick like that. So, oh geez, I forgot to make it windowed in my build. It was like huge on my other screen. So let me go back to my build settings real quick. Move this over here. Resolution, windowed. Sure. It's a little larger than I'd like, but it's fine. So now I just need to wait for that to rebuild. Okay. Server only. Let's boot this up as a client. I have, okay, so it works. It works when I'm running as a client in dedicated server. So that tells me that the issue is with the client host. I'll look into that. Obviously, I'm not going to be running server auth as a client host, but I still want it to work just because it'll make testing a little bit easier. You'll notice now if I try to like move my thing up, it's snapping me right back. Also, if I try to increase my move rate to like 40, you'll see that I'm still limited to the normal move rate. So in case this is unclear, let me set it back to 20 just to show you. This is what it looks like normally. Okay, so get an idea about how fast that was. Now if I move this up to something insane like 900, it's getting across the screen at the same time. That means the server auth movement is working. Obviously the flickering is disgusting, and I can still see the movement because it's like, even when there's no desyncs, I can see it because like I said, fixed updates at 50 milliseconds, so it's kind of gross. That's part of the graphical smoothing stuff, and I'll be going over that the next stream. You can't do server authoritative movement with pun. It's all client side. It's not possible. So it seems to be working for dedicated server anyway. So there's something going on with the fact that I'm running it as client host. Let's take one more super quick look at what might be going on. Yeah, I'm not too sure. I'll figure it out though. And it's definitely only a client host issue, so that's not really a bad thing, I guess. It's probably just something fighting with something else. So let me just look at some of the code real quick. Process it. Yeah, I mean, it all looks fine. I'll figure it out though. It's not really a huge concern because, like I said, it's only causing problems as client host. I will fix it though because I don't like having unknowns in my code. It's probably something really silly. But that's it for today. This stream will remain up for the time being. Like I said before, or when someone asked rather, this stream and all future streams will remain up at least until the project is finished. This is going to be a supporter project, both the source code and all that jazz. I don't know if I'll remove the stream or not at that time. I honestly can't say. But until that time comes, which will be a while, the stream will remain up, and I'll probably leave it up for like a week after too, if I do decide to remove it, just to be fair, give everyone a chance to watch it and get it. So next video I will be covering that silly little client host fix, and I suppose smoothing out the graphics, and that will basically wrap it up for the simple auth movement example. So in an hour and a half, we got pretty much everything done from scratch. It's not too bad. I imagine the fixes are going to be very simple, and I know the smoothing is very easy as well. So until then, you're always welcome to jump in my server, ask questions, although I probably, if I'm being quite honest, I probably will not provide code or stuff I haven't covered yet in the video, because I simply don't want to repeat myself, because I will be making another stream sometime soon down the road. But otherwise, you're welcome to jump on my Discord. It's at the link of any of my mirror videos. It's also on my YouTube, I guess, wall. I don't know if it's called wall, but where you can see comments and stuff. It's the most recent post I've made. I'm going to go ahead and take off though. Thank you for watching.